Hey, what's up, interweb? Today we're going to, actually, this is going to be hopefully a review for you. Roots, radicals, and root functions. What could be more fun? Okay, the first thing let's talk about just as a review are squares. SQ. And that is, if we have 5 squared, what does that mean? The base number, the big one at the bottom, gets multiplied by itself twice. So it's 5 times 5, which is 55. No, 25. Okay, now, or you can say that negative 5 times negative 5, negative times a negative is a positive, and 5 times 5, of course, is 25. Now, in math, it seems like we do everything frontwards and backwards. So if we have, excuse me, the square root of 25, what does this mean? There's a little 2 in here. We just don't write it because we don't have to. And we're lazy. The square root of 25 means what number times itself is 25? This is plus or minus 5. Plus 5 times plus 5 is 25, and negative 5 times negative 5 is also 25, just like we had up here. So the square root of a number is plus or minus whatever this is. Okay. What about the square root of, and again, that 2 is not going to be there. It's assumed to be a 2 if it's not there. The square root of 16 is plus or minus, this plus over top of the minus means plus or minus 4, right? And the square root of 9 is plus or minus 3, blah, blah, blah. Okay. Now let's talk about a few vocabulary words. This is the radical. Not super whiz bang important, but you are going to see this term from time to time. This is the radical, and the number inside of the radical, if we had the square root of A is the radicand. A-D-I-C-A-N-D. M-O-U-S, oh yeah. Again, the A is the radicand. Again, not super whiz bang important. Okay. And the 2 here is the index. Okay. And this is the radicand, R-A-D-I-C-A-N-D. And this thing here is the radical. And again, you're not going to see this term a whole lot, but you will see it occasionally. And let's see. Now, for right now, we will have a way of dealing with this at some point. But if you have the square root of negative 49, now what number times itself? What number times itself is negative 49? There is no number times itself equal to a negative number, so this is undefined for now. We will, as not a real number. And as I said, we'll have a way of dealing with this later, but for right now, we're just going to call it undefined or not a real number. Okay, the square root of 0 is what number times itself is 0? 0. Can't say plus or minus here because 0 is just 0. It's neither positive nor negative. Now, if you have this, 36 over 16, this is the same thing as the square root of 36 over the square root of 16. You can break it up like this if you want. So that's 6 over 4, which is 3 over 2. Right? Right. Actually, plus or minus. Okay. Now, what if you have now what if you have what if you have minus the square root of come on, stupid thing. 25. Now look, this is nothing more than order of operation. Now the radical is actually is equal to minus 25 to the 1/2 power. And we're going to go into this a little bit later. But what would we do first here? Do we have any, this is Pemdas, order of operation. Do we have any parentheses? No. Do we have an exponent? Oh, yeah. Okay, so the radical here is the same thing as, we'll treat that like a what? An exponent. So what's the last thing we would do here? Add and subtract. So what this really says is subtract the square root of 25. So our answer here is negative 5. Okay, when the negative is on the outside of the radical, all that means is to subtract that. Now, cube roots, O-O-T-S. Cube roots means what number times its own self. That's what we say in North Katy. So about right here, you need to stop and get you a drink of Diet Coke. Oh, that's good. And the way we write the cube root is the 3 here for the index and 8. Now the cube root means, again, what number times itself 3 times is 8. That's not plus or minus, it's only plus. That's 2. Right, right. Okay. And if you forget, ooh, look how old my hand looks. 2 times 2 is 4. 4 times 2 is 8, so we're correct. Now, what is get this if you're so smart. The cube root of 27. What number times its own self is 27? It is 3. 3 times 3 times 3 is 27. And again, not plus or minus. Now, what if you have this? The cube root of negative 64. What number times itself is negative 64? Negative 4 times negative 4 times negative 4 times negative 4 is 64. So our answer here is negative 64. All that stuff. This means this. So the cube root of negative 64 is stupid, not 64, you hammerhead. It's negative 4. Sorry, I'll do better. No, I'm not going to do any better. And the cube root of negative 8 is negative 2. Negative 2 times negative 2 times negative 2 is negative 8. And let's see. Our handy dandy calculator will deal with this. First you turn it on, right up here. The big graphing calculator will deal with this also. Now, what we have to do is, I think it's this one. No, stupid. Well, first you turn it on. We're going to take the cube root of it, so it's 3 cube root of negative 64. Okay, the cube root of negative 64 is negative 4. So we are correct. Okay, and the big graphing calculator will deal with that also. As I remember, it's at first you turn it on. Where is that on? Here. Go to math, right here. We're going to take the cube root, so we put a 3 in, math. Oh, it already has a cube root thing here. I forgot. Stupid boy. Okay, math. Cube root's the number 4. And now here you have to put in, now this little calculator does not make a distinction between subtract and negative. The big calculator does. If you put in this thing, you're going to get a bad answer, undefined or something stupid. But here's the negative key. Negative 64. And again, before you leave this screen or hit enter or whatever, make sure you entered it right. And hit equals, and we get negative 4. Okay, so we clear and turn it off. Okay, now, get this if you're so smart. Radical and a 4 in the index. In other words, what number times itself 4 times is 16? And we have the answer there is 2. 2 times 2 is 4, 8, 16. And live long and prosper. Okay. And again, the calculator will deal with this if you want it to. The 4th root of 81, I think, is 3. And again, the calculator will deal with this. And if you have minus the 4th root of 16, now remember, what is this saying? It's saying to subtract this. And that is negative 2, I think. Yes. Okay. What else? Oh, graphing radical expressions. What could be more fun? SSIO. Graphing radical expressions. Hallelujah. Praise God. We have these graphing calculators. If you don't have one, I would suggest getting one. It's going to help you not only in this class, but in the next one. Well, I tell you, Circle K has the best Diet Coke. And good, crunchy, crushed ice. F of X Remember, f of x is nothing more than y. We just have to have a better way of writing this. It's the function of x. If the function of x equals the square root of x, what is that going to look like? I think my phone's ringing. They'll let it ring. Okay, now the way we do this is we make a nice pretty table of values. Remember where we did x and the function over here and f of x. Now remember, f of x is nothing more than y. So if we take some perfect squares, 0, 1, 4, and 9. F of x, again, is the square root of x. So the square root of 0 is 0. The square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Now, we have this. And if we have, remember, this is our x-axis, this is our y-axis. Now, y, remember, is f of x. So if this is like 5, and this is 10, and then we have x is 5 and 10. When x is 0, y is 0. So we have this point right here, 0, 0, 1, 1, to the right 1, and up 1. 4 and 2, 4, and 1, 2. You can see even with my horrible handwriting and my horrible graphing skills that we're not going to have a linear function here. It's going to be something other, in other words, a straight line. 4, oh, it already did 4 and 2. 9 and 3. 9 is about here. 3 is about 1, 2, 3. So what are we going to have here? We're going to have what looks like a parabola opening to the right. Now remember, this is going to be 0. This could be -1, -2, and -3, which will give us this, probably. Now you can do this on the handy dandy graphing calculator. First you turn it on, go to y equals, right here, y equals, and we do the square root. Now the square root is the one that's above x squared. Whoops, can't see that very well, can you? If you look, it's in, depending on what calculator you have, it depends on the color. This particular one, if you'll look at the second button is blue, and the square root thing, you can't see it, but it's also blue. So we hit second and x squared. Look up here, and we have square root of x. This is the x here, x, the variable. Double check and make sure you have it entered right. Go to the graph, and you'll see that that's what we look like. And even as bad as my graphing is, you can see that we're probably correct. Now, why don't we have the bottom one? Because what you'd have is insert. Where's the insert key? There it is. Negative x. What happened? stupid boy. Here we go. Well, leave it to me to mess that up. Anyway, there'll also be this also. Okay, now what is the domain? Remember, domain goes side to side, and the range goes up and down. So how far to the right is this going to go? We know that it ends at 0. So the domain does not include 0, or does it? Yeah, it does too. Sorry. I'll do better. It does include 0 because the square root of 0 is 0. So it includes the 0. Now where does it end? Now remember, domain is this way. Where does it end over here? It does not. Okay, and the range, excuse me, the range goes up and down. So what's the smallest number this can be? We're not talking about this here. We're only talking about this one. Where does it start, or where's the lowest part? Again, 0. And where is how far up will, no, see, I came down, but it actually doesn't. It keeps going this way. But how far up does it go? It also goes to infinity. It just goes to infinity very, very slowly. Okay, domain and range. Now, okay. Now, what if we have, see how far we're going to go today. 10.3. Are we doing that today? One and two. Okay. Now, what if you have this? F of x, remember f of x is y. Just another term for y. The cube root of x. And remember, this means y equals the cube root of x. Now, what will this look like? If you have x and f of x. Okay, we don't want to start at 0 here. We want to go, to the left also. -8, -1, 0, +1, and 8. Okay, and what is this is the cube root of x. So the cube root of -8 is -2, -1, 0, 1, and 2. Okay, I should have made this graph. You know what? Let me move this down. Should have made the graph more bigger. -5, -10. Oh, really didn't. Yeah. And +5 and +10. And 5 and 10 and -5 and -10. Okay, so -8, -2. -8's about here. -2's about here. -1, -1. -1, -1. 0, 0. And 1, 1, to the right 1, up 1, to the right 8, and up 2. So you can see that, again, we're not going to have, this is not going to be linear. Okay, it's going to look like that. So let's see, let's put it in our handy dandy calculator. First you turn it on, go to y equals, and now I've already forgotten what our, oh, we have the cube root of, so we go to math, our cube root's number 4, and I've already forgotten what our, oh, x, stupid hammerhead. Okay, cube root of x, go to the table, and you can see that even as bad as my graph is, that we are correct. Excuse me. Y equals, clear, turn it off. You can see how this calculator is your friend. Say hello, friend. Now, what is our domain and range? D-O-M-A-I-N. Okay, where does it begin? Remember, domain is side to side, and this goes on forever in either direction. So we have negative infinity to positive infinity. It goes on this way in the negative territory forever. And of course, it does not end, so we use a parenthesis. Same thing with the positive side. Where does it end? It does not. And the range, this one's kind of harder to see because it goes up and down so slowly, but it does go up and down infinitely. Negative infinity and positive infinity. You're probably going to get this on the final exam. Don't hurry on this, but stop and think it through. Okay. Okay. Now, a different way of writing the square root of 5 is, what's the exponent here? 1. What's the index here? A 2. You can also write this as 5 to the 1/2 power. Okay? The exponent on the radicand goes on the top, and the index goes in the denominator. So if we have the cube root of 3 squared, oh, I shouldn't have used, let's say 8. Sorry. The cube root of 8 squared is 8 to the 2/3 power. Okay? The exponent of the radicand goes on the top, is the numerator, and the index is the denominator. Okay? And if we have the 4th root of 11 to the 7th power, that would be 11 to the 7/4. Okay? Exponent of the radicand, and the denominator is the index. Okay? And if we have the 5th root of 13 to the 4th power, this is 13 to the 4/5. Okay? Not super duper whiz bang important, but it is one of those things again that you will that you'll see from time to time. Okay, let me give you a preview of what we're going to do Wednesday, and that is this. If we have, excuse me, the square root of 36 times 4, we can rewrite this to have each one of these numbers under a separate radical. Square root of 36 times the square root of 4, which is 6 times 2. Square root of 36 is 6, square root of 4 is 2, so that is equal to 12. Okay? Or you can multiply this. 36 times 4 is 144, and the square root of 144 is, again, plus or minus 12. Okay? Okay. And we'll talk more about this on Wednesday. This will be on YouTube and on WebEx, if I can get it did right. Yeah, what are the chances of that happening? Okay, well, y'all take care. See you later. Bye-bye. Bye, Bonds.